Hello, developers. I do have a note for you. Stop trusting your LLM. It is lying to you. We all love ChatGPT until it hallucinates a court case that doesn't exist, or invents a Python library that breaks your production code. Standard AI models are frozen in time. They don't know your private data, they don't know your company secrets, and when they don't know the answer, they guess. But what if you could force the AI to take an open book exam? Enter RAG, Retrieval-Augmented Generation. Instead of memorizing the internet, we give the AI a live connection to your specific data, your PDFs, your Notion, your SQL database. Pro tip, don't click off yet. Somewhere in this video, I've hidden a specific self-correction prompt template that usually costs $2,000 to license. If you find it, your RAG pipeline becomes basically invincible. You do not want to miss that. Today, we build this pipeline from scratch using Llama 3 and Groq. Let's fix your AI. We are going to stop the hallucinations. We are building a Retrieval-Augmented Generation, or RAG, pipeline from scratch. The goal is simple. We want to compare a raw LLM, which just guesses based on its training data, against a RAG-enhanced model that actually reads documentation before answering. I've got my VS Code open. Let's start coding. First, let's import our tools. We need web-based loader to fetch data from the internet. We need recursive character text splitter because we can't just feed an entire Wikipedia page into the model at once. We need to chunk it. And of course, FAISS to store our vectors. Notice I'm also importing ChatGroq. If you haven't used Groq yet, it uses LPUs, language processing units, instead of GPUs. It is incredibly fast for text generation. I'm also loading my environment variables with .env. Make sure you have your groq underscore API underscore KEY stored in a .-env file so you don't leak it to the internet. Now let's give our model a brain. I'm using web-based loader to scrape the Wikipedia page for artificial intelligence. You can replace this URL with your own company documentation, PDF, or Notion link. But here is the catch. LLMs have a context window. We can't just dump raw HTML text in there. So I'm using the recursive character text splitter. I'm setting the chunk size to 1,000 characters with a chunk overlap of 200. Why the overlap? It ensures that we don't cut a sentence in half and lose the meaning between chunks. It keeps the context flowing. This is the most critical part, embeddings. Text means nothing to a computer. Numbers mean everything. I am using the All-Mini LML 6v2 model from Hugging Face. It's lightweight, fast, and runs locally on your CPU. It converts our text chunks into vector lists. Then we store these vectors in Face, Facebook AI Similarity Search. Think of Face as a super efficient librarian. When we ask a question later, Face won't read the whole book. It will mathematically find the 3 or 4 paragraphs that are most similar to our query. This is what makes RAG fast. Now, let's bring in the intelligence. I'm initializing chat Groq with the model Llama 3-70B-8192. I'm setting the temperature to 0. Why 0? Because we are building a factual bot. We don't want it to be creative or artistic. We want it to be precise. I'm also defining a prompt template here. Notice the structure. I am explicitly telling the model, answer the question strictly based on the context provided. This is the guardrail. If the answer isn't in the context, the model should ideally tell us rather than making things up. Here is the core experiment. I'm writing 2 functions. Function 1, without underscore rag. This is a standard API call. It takes the user's question and sends it straight to Llama 3. It relies entirely on the model's pre-trained memory. If the data is new or specific, it will fail. Function 2, with underscore rag. This is where the magic happens. We create a retrieval QA chain. It takes the question. It sends it to the retriever, our face store. The retriever pulls the relevant chunks. It combines those chunks with the original question. Then it sends that package to the LLM. This is the difference between guessing an answer and looking it up in the textbook. Finally, let's build a simple loop so we can test this interactively. I'm asking the user for a query. Then, I'm running both functions side by side. I'm printing the without RAG answer first, then the with RAG answer. This way, we can see the hallucination versus the fact in real time. Moment of truth. Let's run Python main.py. We are facing few module spelling errors. We'll fix them ASAP. We do have few more errors as well, and as you know, modules keep depreciating and updating over time. We need to take care of that and be aware. I told you there was a surprise. Here it is. Most people use a simple prompt like, answer the question. That is weak. If you want enterprise-grade reliability, use this prompt. Show the code. It forces the model to act as a QA engineer first. It has to audit its own answer before it speaks to the user. This simple logic switch kills 90% of hallucinations. Screenshot this now. You're welcome. Query. What is AI? Look at the first answer. Without RAG, it's good, but it's generic. It sounds like a Wikipedia summary because Llama 3 was trained on the internet. Now look at the second answer, with RAG. It is citing specific phrases from the text we just loaded. It is grounded in the documents. Both are correct here, but notice how the RAG answer feels more structured based on our prompt. That is the power of controlling your data context. And that is how you build RAG in under 100 lines of Python. If you want the source code, check the description. Thanks for watching. Follow and subscribe for more AI-related coding.